Okay, today we're going to extend what we did last week as far as the factoring goes, and we're actually going to solve these equations now. So you guys have been solving, but like I said, we do a lot of extensions and tougher type problems in this class. We're going to spend a while in this section. There's a lot of stuff going on with it. So first thing, just recap what solving means. So you guys have all seen equations before. The only difference from last week is we're adding this equals 0 piece. So you're trying to find the value or values for x that turn the equation into 0. So what can you plug in that make them 0? Linear equations are really easy. You guys know, isolate the variable, do the opposite, all that stuff. Okay, quadratics and other things, we got to try a bunch of different methods. So if you see this one right here, we're going to factor. And then you're just going to set each little piece equal to 0. So you guys will remember we usually take the opposites out of here. Be careful if they're fractions. So x minus 2 equals 0. Okay, those are our two solutions. Now, if you go to your calculator and you plug that in, the nice thing about this is you can always check if your solution is correct. So before you turn something in, you can kind of know how many of those solutions you got right. So we go here, we go to the table. When we plug in a 2, we get 0. When we plug in a 4, we also get 0. So you know you did it right. To make the connection again, it's just a quadratic. There's our two solutions where it crosses the x-axis at 2 and at 4. Now, I can really only give you a bunch of hints and tips and some examples for all these different strategies. Eventually, I'm just going to give you guys kind of a mixed bag of equations and expect you to be able to solve them. So I think the first thing is, can you factor? So the last one, about as simple factoring as it gets. Make sure you get it set equal to 0, though, and check for GCFs. GCFs make these make problems easier. They make them smaller for us. Second type is it's set up for a square root method. So that's where you got your variable and some other things kind of in a blob quantity squared. So you really only see the x once, as opposed to the last one where you saw the x two different places, x squared and an x. Quadratic formula, you guys have used it before. It always works. I kind of like it, but it only works with quadratics. If you have something cubed, you're kind of out of luck with the quadratic formula. Big thing with that, though, needs to be equal to 0 and in the correct form. You're not going to do quadratic formula with the square root method. Fourth one, completing the square. Not sure how much you did in Algebra 2 of that, but we're going to spend a lot of time on those types of problems. And lastly, you can always graph or check these things in your calculator, as I've shown you guys. So we're going to kind of hit on these topics and practice them for a few days. So first thing, factoring. Okay, so this one's a little bit tougher than the last one we did. And I just want to remind you guys, there's always as many solutions as the power. So when you look at this, you have an x squared. So we know when we're all done, you need to find two solutions for me. Now, factoring isn't the only way to do this one. You can complete the square, you can do quadratic formula, and you can graph it in your calculator. Okay, but it factors, so we're going to do it. First thing is you got to make sure it's set equal to 0. You don't want to factor anything like this right now. It's not going to work for you. Get everything on the same side. I'm going to move these over, so that way this stays as positive 3x squared, which I like. So this goes to minus 9x and minus 84. Okay, I check for a GCF. They all have 3 in common. So x squared minus 3x, so this would be 28. Now, the 3 isn't going to provide any kind of solution. So if you want, you could technically divide these by 3. That would go away to a 1. This would just stay as a 0. If it was a 3x, it would provide a solution. So really the problem is just this. The same solutions for this one work for your original. Okay, well, it multiplies to 28 and adds to negative 3, minus 7, and a plus 4. So your solutions, 7 and negative 4. If you go to check this one in your calculator, though, you're going to have to put it in as far as something equal to 0. So it's going to be kind of hard to check this one right here, but if you plug this one in, you'll see if your solutions work. So I'm going to pause that and take. So I put in the quadratic where it's all on the same side. Go to your table. We can see at a 7, we get a 0, which is good, and also at -4. So we know we did it correct, 2 solutions. Here's a harder example for factoring. Now, if you see this, over here in the box, there's a few key do not do. It's really tempting to divide everything by an x. Okay, but if you do that, you eliminate a solution. And that's a problem, because this is x cubed, so we need 3 solutions. If you divide by x, you just got rid of one, and you're not going to have one anymore. So don't do that. Also, do not factor without setting equal to 0. So by that I mean going, oh, well, I'm going to pull out a 6x here, so I'm left with x squared plus 5 equals 28x squared. That doesn't do you any good. You can't set this equal to this and this equal to this. Okay, it's not going to work. You want to set it equal to 0. So don't do this either. Okay, set it equal to 0 and see what happens. So in this case, I'm going to move the 28x squared over because I already have my largest variable as positive, so I want to keep it that way. Okay, make sure you set this equal to 0. Now, I am going to pull out a GCF, but it's different than doing it up here. So I'm going to pull out a 3, not a 3. 3 doesn't go into 28 very well. How about a 2? So I'm left with 3x squared minus 14x squared, not x squared, and x plus 15, and this thing equals 0. I guess I should probably pull out a 2x. There we go. Okay, so we pulled out the GCF. Now, you're still going to need to factor this one in here. Okay, so let's see how it works. We'll do the x method into grouping. So this is 45, negative 14. So that's going to give me 9 and 5. So if I went -9, -5, so then I write this out. 3x squared minus 9x minus 5x plus 15. GCF it. Make sure you change this sign when you pull that negative out. These match up, so I'm good. So I'm going to take this one as well. So this whole thing breaks down . Now, it's all factored, it's all linear terms, so I can find all my solutions. Everybody's going to grab a 3 out of here. That's pretty easy. You guys are going to set this equal to 0, add 5, divide by 3. There's one solution. We said we needed 3. Your other one comes from here. What you have is this blob equals 0. And it's the easiest solution out there. 0. Okay, there's my 3 solutions. Now I'm going to check it in my calculator, but again, you have to set it, have it equal to something with a 0. So I'm going to go back and check this one. Again, I'm going to pause it real quick, throw it in the calculator. So this is in the calculator correctly. Now 5/3 isn't going to show up on the list. So if you hit second window and you go down and you put this first one at ask, we can input it in. So now it's going to be blank. 0 works, 5 divided by 3, that works, and 3 works. There's our 3 solutions. Okay? Now, sometimes, eventually, we'll get into stuff where you pull out the GCF like we did here with the 2, and maybe this in here doesn't factor, so maybe you have to do quadratic formula off of there. Next one, square root method. So you could sit there and you could double distribute this x minus 3 quantity squared out. Okay, you could distribute a 2 through it, you could subtract a 4, you could set it all equal to 0. But if you have this one, I just call them blob squared, try and isolate that. So move the 4 to the other side. Okay, I'm going to cut this thing in half now. So basically, some number minus 3, when you square it, equals 17. So we all know to get rid of squaring things, we square root them. But the trick is to remember the plus minus there. Because if you say, oh, a number squared is 9, your answers are 3 and negative 3. Because that squared lets us throw a negative in there, multiply it by another negative of the same thing, and get a number. So the way we should write this, the square root of quantity x minus 3 squared, there's a 2 out here, it'll cancel with that 2. Now this equals plus or minus the square root of 17. If it's some ugly decimal, we'll just leave it like that. Now you can see how I left a space because I want to isolate that x. So I'm just going to swing this 3 over. 3 plus minus square root 17. Okay. We want to check our answers now. It's going to be a little bit different. Let's clear this out. Let's put this in exactly how it looks. Now, you could move the 30 to the other side, or we could just know that we're not looking for a 0, but we're looking for 30. So we're still on ask, which is good. So if we come in here and you say 3 plus square root of 17, we get a 30, which is exactly what we want. Okay, so this side, when you plug in one of these numbers, equals this side. Now, when you plug in the same thing with the minus, we're going to get the same answer of a 30 as well. So again, we can check our solutions always. So there's your square root method. Quadratic formula. So a lot going on here with that. I use it anytime I stare at something for more than 30 seconds and I can't get it to factor because it'll work for you every single time. The trick is, like I said before, you got to make sure it's a quadratic. So the last example we did, well, 2 examples ago, this one, it would not work for that. As far as if you move the 28 over, this example right here, you cannot do quadratic formula with these. This is not A, this is not B, this is not C. However, you can do quadratic formula right here, because it's a quadratic. This one, no. This one, yes. Okay, so keep that in mind. You guys have all seen the formula before. Some of you guys may know the song. I don't sing and dance, so you'll just have to have it in your notes or at the back of your book to look. Keep in mind this guy right here is called your discriminant. That'll help us figure out how many real solutions. So everything we've had so far has been real solutions, no complex number stuff with the i's. So if this comes out positive, you get 2 intercepts, 2 real solutions, just like we've had for the last couple of problems. If that is a 0, this whole thing goes away. You're left with negative b over 2a, which is the vertex formula, and your vertex is right there. If that discriminant comes out negative, you have no real solutions because it never hits the x-axis. Okay, so quick little recap of those. So like I said, it won't work here. unless you pull out that GCF. It will work here, but the problem is you have to make sure it's equal to 0. So anytime you look at something, you can't get it factored, you don't want to try something else, just do quadratic formula. Okay, but you got to obviously be careful how we input all this stuff. So we'll go 3x squared. Move this over and put it right in the middle there. Make sure it equals 0. Now you have your A, B, and your C values. So you guys have done these before. Opposite of B is positive 4. Notice I'm not even putting the sign in there, because no matter what it is, it's always going to be 16, whether it's a positive or a negative. Minus 4 times 3 times 2. Everything's all over 2 times 3. Okay, so let's start simplifying. So this is 16 minus 24 all over 6. So this is square root of negative 8 over 6. So now we're running into some complex number stuff again. So you guys will remember we can pull out an I and make this positive square root of 8, because we know I is equal to the square root of negative 1. Now you don't want to leave a square root of 8 because it has that perfect square in there, simplifying the radical stuff. So 4 plus or minus 2i squared to 2 all over 6. Okay, coming from the square root of 4 for that. Now, because you got a 4, 2, and a 6, we can divide all of those. This is going to go to a 2. This is going to go to a 3. So your answer's 2 plus or minus, the 2 went away, I squared of 2 over 3. Only problem with this is we can't check that answer in our calculator because we're not able to input the I. But what we can do is check the original quadratic and see if it hits the x-axis or not. So if I graph this, okay, I can see it doesn't hit the x-axis there. It never drops below. So we could zoom in or we could change this window. Okay, it never hits. So at least you know you do have a complex solution. We may or may not have the right answer, but at least you know you're on the right track. Our next example is going to be completing the square. The more you do this, you'll find it's actually quicker than you guys are used to, and it's actually really helpful because it puts you right into the square root method. Few suggestions with it though. You have to factor out the A value, and it's obviously a whole lot easier when the B value is even. Your steps, again, are over here. Like I said, factor out the A, take half of B and square it, add it to both sides so you're not breaking any math laws, and then factor and solve by square roots. So if I saw this one right here, sure, you could move this over like this. You could try and say, okay, what multiplies to 10 and adds to 6? Nothing would work, so factoring's out the window. You could easily do quadratic formula, okay? But we want to work on completing the square. Notice the 10's already over here by itself. So the way I set these up, leave a space. If it helps you to use a different color, half of 6 is 3, you square it is 9. You can't just randomly add 9 to one side without doing it to the other. Okay? Now you have to remember to factor. So these are always going to factor to the same blob, quantity squared. It's always half the B. Now this equals 19, and you're right into a square root method. Square root, the plus minus. So x plus 3 equals plus minus square root of 19. Move that over. and those are your solutions. You check it in the calculator. If you threw this into y1, you plug those in, you should get a 10, not a 0. Okay, so just keep that in mind. All right, a more difficult example is this next one. Because of step 1 here, you have to make the a value a 1. So what I mean by that is this. You don't want to pull out the GCF, just the a value. So you guys should agree that that's the exact same thing. Now, complete the square. Half of 4 is 2. 2 squared is 4. But you're not really adding 4 because you have this to take care of. So you're really adding 12. That's what makes it a little bit more difficult. Now when you factor, again, it's always going to be half the b quantity squared. Don't forget about the 3. And this equals negative 12. Now you're right into a square root method problem, but you got to take care of this 3 first. Now we square root, making sure we do the plus minus. Square rooting a negative number is going to give you that complex number things you've looked at before. So square root of 4 is 2. If it's negative, throw the 2i with it. Swing this over. Negative 2 plus minus 2i. Okay, so there's a quick recap of different methods you're going to see. We'll start class tomorrow with factoring by grouping 1, so requiring some different strategies. So you should be able to quadratic formula, complete the square, factor, and check your answers in your calculator. So we'll see you guys in class, and we'll start practicing those concepts.